Alright, so we're going to take what we learned in the past few videos and apply it to what we're going to do in this video, which is solving exponential and logarithmic equations. I'm going to make two videos, and so this first one will be about solving exponential equations. Now, if we're solving exponential equations, there are three steps that you need to go through. The first step is you need to isolate what is being raised to the power. So basically what that means is to just get whatever's being raised to the power by itself. So that's the first thing you need to do. The second thing you need to do is rewrite your exponent as a log. And so this is when we're going to do shell snail. Alright, and then the third thing you're going to need to do is to then just solve for x like you would normally do. And so the fourth step, you'll have a fourth step on logarithmic equations, and that's going to be to check your answers. You do not have to check your answers for an exponential equation because you can plug anything into an exponential equation. The domain is all real, so you don't have to worry about checking your answer and making sure that it's correct. So let's do a couple of examples. We'll start out easy. So for number one, what's being raised to the power? That's what I'm going to ask myself first. The e is what's being raised, and so that's what I need to get by itself, e to the whatever power. Since it's already by itself, then I'm going to go on to step 2, and that's going to be rewrite it as a log. So I'm going to shell snail, and when I do this, you can either show this step or you can go straight to ln. I don't really care either way, but I would go ahead and write this. This is going to be log base e of 72 equals x, and remember, log base e here is really just the same thing as the natural log of 72 equals x. And so then I'm going to go plug that in my calculator. Alright, so when I plug this in, this is going to be natural log of 72. And I'm going to round this to 3 decimal places. So whenever you do these kinds of problems, just go ahead and round them to 3 decimals. So this is going to be 4.277. So x equals 4.277. And that's how we do that one. Okay, number 2. This one's a little bit different, but it's still not too hard, because the only thing that we have to do is get that e to the x by itself. E is what's being raised, and so I need to get rid of the 5. So I'm going to subtract this 5 from both sides. And so this is going to be e to the x equals 55. And so then I'm going to do the exact same thing as last time. And when I shell snail, we can either go ahead and just say it's going to be the ln of 55 equals x, or I can say log base e of 55 equals x and then change it over. I'm going to go ahead and say x equals the natural log of 55, and then I'm going to plug that in. So the natural log of 55 is 4.007. So x equals 4.007. Alright, number 3. On this one's a little bit different because we don't have a base e anymore. We have a base that's a number. And so 5 is what's being raised to the power, and every bit of that, negative x over 2, is in the power. Okay, so we can't get rid of anything that's in the exponent until we rewrite it as a log. So the only thing that I can really do on this one is to go ahead and shell snail. So when I rewrite this with shell snail, I'm going to say this is log base 5 of 0.20 equals negative x over 2. Now, to solve this, I need to know what log base 5 of 0.0 or 0.20 is. And so I'm going to do log tall divided by log small. So log of 0.20 divided by the log of 5 is going to give me negative 1. Okay, so negative 1 is going to equal negative x over 2. And so then this is just an equation that I'm going to solve like normal. If it helps, I can put that over 1 and think about this as cross multiplying. So when I cross multiply, it's going to be this diagonal equal to this diagonal. So let's do this negative 1 times 2 first. That's just going to be negative 2 is going to equal negative x. And so then I'm just going to divide by negative 1 to get rid of the negative. And so x would equal 2 for that one. Alright, this one is a little different because you can tell that this has 2 different bases in it, and they're being raised to 2 different powers. Okay, and so this one is a type of equation that we've actually solved back in Unit 1. And we're going to use a method that we used in Unit 1 to solve this. Hopefully you remember. But I'm going to use the U method, okay, because this is like a quadratic type equation. If I were to take e to the x and square it, then I would multiply these two numbers, or these two exponents, and get e to the 2x. And so this is, the first term is just that middle term squared, and so I can use u for this. And so that's how I'm going to do this. I'm going to let u be the middle e to the x, and then I'm going to say u squared minus 3u plus 2 equals 0. And then factor it like I would normally factor this. So this would be u, 2, 1, minus, minus. And so then u equals 2 and u equals 1. And so now I've got to make sure that I plug this back in for u. So this is going to be e to the x equals 2 and e to the x equals 1. And so then it's kind of like two different equations that I've got to solve. And so I'm going to solve those the same way that I normally would, like I did in the first example. I'm going to shell snail. And we know that when we shell snail and we've got base e, that's just log base e, or ln of 2. So I've got x equals ln 2, x equals ln 1, and I'm just going to plug both of these in. So natural log of 2 is 0.693. And over here, natural log of 1 is just going to be 0. Okay, so then both of my solutions are 0.693 and 0. Alright. 5. Okay, so this is another kind of exponential equation. And so I want you to try this one on your own first. This is another U problem, so I want you to try this one on your own first. So just hit pause and then come back and watch me do this one. Alright, so here's the worked out solution for number 5. The answers are actually, or the answer is actually x equals negative 0.347. And so if you got that, then you can just skip on past this example. But if you didn't, this is what I did. I let u be e to the 2x, that's the middle term, and then replaced all of those with u's, factored, and then got u equals 1/2 from this factor and u equals negative 4 from this factor. And so then I had to plug back in e to the 2x for both the u's. And so then I shell snailed. And so once I shell snailed, I ended up getting the natural log of 1/2 equals 2x, and the natural log of negative 4 equals, no, I shouldn't have e to the 2x there. This should just be 2x. Alright, and so then to solve for this one, I took the natural log of 1/2 and divided it by 2. So natural log of 1/2, and then all of that divided by 2 is that negative 0.347. And so that's how I got this first answer right here. Now, if I go ahead and try to take the natural log of negative 4 and then divide that by 2, so natural log of negative 4 divided by 2, that's just going to give me a non-real answer because I cannot plug a negative into a natural log or a log. And so this one doesn't give me a solution, but alright, so there's that problem. Alright, we got one more left to do, and this one's a little bit different. So when we're doing this problem right here, this one is exponential. So if you're given this equation, you're going to see that it's exponential because I've got things that are being raised to exponents and I don't see any logs anywhere. So I'm going to do this one by the exact same method that we've been doing. I'm going to shell snail, and you can't really get these any more by themselves than they already are. So you're going to want one exponent on one side, one on the other side, and that's pretty much how it's going to be given to you. So I'm going to go ahead and do shell snail. So when I do that, this is going to be log base 25 of 5 to the 6x minus 3 equals negative 2x. Now, if we have a log, this exponent right here can be taken and moved down to the very front of the log. So this is going to be 6x minus 3 times the log base 25 of 5 equals negative 2x. Now, this log base 25 of 5 is just a number, so I'm going to go find what that is in my calculator. So I'm going to do log tall divided by log small. So log 5 divided by log 25. And so that would be 1/2. And so really here, this is what I've got. 6x minus 3 times 1/2 equals negative 2x. Now you can do this one of two ways. You can either distribute this 1/2 to this 6x minus 3 and just distribute it over. Or what I can do is, since it's being multiplied by the 6x minus 3, I can just divide the 1/2 off both sides. And that's typically how I like to do it. I think it's a little easier. And so in my calculator, I'm going to show you, if you do negative 2 divided by 1/2, I'm going to put that fraction in parentheses, that's just going to be negative 4. So over here, this is what I've got. 6x minus 3 equals a negative 4x. And so then I've got to get my x's on one side and my numbers on the other. So I'm going to add the 4x. I'm going to add that over. So that's going to be 10x equals, and then I'm going to add the 3 to the other side, so that's 3. And so then x would be 3/10. And that would be my answer. Now, for all of these problems, you can just take the answers that you got and plug them back in for x and see if it gives you a correct answer. So for example, if you wanted to check this problem, then I could say, okay, if x is 2, then I would say 5 to the negative 2 over 2. Let's just plug that in and see if that works. 5 raised to the negative 2 over 2 is going to give me 0.2. Okay, and so that's what it needs to give me, because that's what it's equal to. So with all of these, you can check and make sure that your answers are correct by just plugging these numbers back in. Now, if you have one like this, that's not a pretty number for your answer. So for example, I got ln of 55 right here. So ln 55, it's this entire decimal. Now, if you wanted to get the exact correct answer, what you could do is take this value right here and store that. So hit this little STO button right here, stow for x. And so anytime I hit x, the calculator automatically thinks it's that 4-point blah 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 mess. And so I can plug that back in and make sure I get the exact correct answer, okay, by saying e to the x plus 5, and that should give me 60. So I'm going to hit e to the, remember x, it's thinking is 4-point blah blah blah, plus 5, and that does give me 60. So you can check and make sure you have the exact right answer by using the stow method or just plugging it back in. And so that's the end of our exponentials video. In the next video, I'll show you how to do logarithmic equations.